Greetings, to Echo Zero Papa Golf Sierra here. This is an update on the OpenFusion LED controller project, OFLC. Here I've got my test strip set up. I've got on the top there I've got RGB 5050 LEDs, which are 12 volts. Below I've got a strip of 5 volt 500 LED WS2812 addressable LEDs, 2812B I believe, off the top of my head, and that's 5 meters. Above that is a dumb one, which are 10 meters. So those are driven off of RGB and a common, and the smart ones are of course power and then signal. So up here at the moment on the top shelf I've got the power supply for 12 volts and 5 volts. I've got a Raspberry Pi Zero W which has a Wi-Fi, and I've also got an Arduino up there which is on a breadboard, which you can't see, which is positioned over there. But this is just a bit of an update which is giving some demonstration and also explaining the fact that there's an API for this. So I basically got sort of smart lighting implemented in my fully open source lighting controller. Background music is by Iceferno, good friend of mine. So I'll just keep that at a reasonable level hopefully. So let's have a look at the web interface. Currently the web interface here is just displaying on a little laptop here. So we get a good angle on that one. Right. This is the web interface. So this is a Flask Python web server which is running on the Raspberry Pi Zero W. Flask is just like a Python framework for creating a web server. That Flask also, primarily the Flask is just an API. It exposes an API that then sends USB serial commands to the Arduino, which is connected over USB serial. The Arduino exposes a USB serial interface which then controls the lights, the different functions in the firmware. So the Arduino has all the firmware, it accepts USB serial interface. The Raspberry Pi just literally acts as a USB to web enabled device, so it hosts the API. On there as well it hosts a HTML page, which the HTML page triggers the API actions, so it's sort of 2 in 1. So on the web interface at the moment we've got power on, power off. We can switch between dumb LEDs and smart LEDs. At some point I'll add RGBW support. Speed control for various speed-based animations. Global brightness control. Auto LDR for auto light dependent resistor. Onboard LDR can adjust to background ambient light levels, also known as a photo resistor. Standard animations: jump free, jump hard, red green blue, jump 7, red green blue, yellow, purple, something like that. I forget off the top of my head. Just 7 different colours. Jump free. You got fade free, which is fading between R, G and B, slowly mixing colours. We got fade custom colour, so it just fades up and down between 0 and 255 over the custom colour selection below. Pass-through mode allows you to have external controllers hooked up, so you can have mine as a master controller and you can pass in an external controller if you want to switch over to that. That just accepts an RGB input on the analog input pins. Solid custom color, so again custom color selection but constant. Down here these require the smart type LEDs, so these are specific just to smart LEDs. Random droplet chooses a random pixel on the string, chooses a random color and updates it and continues to get quite a nice pattern. And you got Night Rider. So if we turn this on, you'll see, if I zoom this out, there we go. So I've got it set. It remembers the last function. It remembers that, provided the power remains to the Arduino. At some point I need to add it into the EEPROM, so it remembers that during the complete power loss. But that's which mode is this? This is a random droplet mode, so quite nice. So I normally use this one because it starts off quite what do you call it, quite low brightness, and then gets quite bright when more pixels eventually fill up. So because the API, which I should be able to show, it basically means you can either use a web interface here, these buttons are triggering the API, or you can actually query the API directly using your address bar, or you can do what I do and query it via curl in Linux, curl. So I've got a cron tab set up that in the morning when I need to get up for work, it curls to the API and switches my lights on. Then when I need to leave to catch my train, it switches them off when I should have left. So if I'm still here and those LEDs are off, it means I'm probably going to miss my train. And that will use this curl running in a cron tab script. Unfortunately this camera doesn't have a pause facility, I don't think, so I'll see what I could do to bring up an example of the API. Stand by. I'm going to have to do this without revealing too much information, which may not work at all. Right, let's see if I can grab... Well, we can just do that, surely. Okay, we can do this. So... bring up a terminal, view full screen. It's going to reveal some information, can't get away with all of it, eh? Now you know the hostname of one of my machines, damn it. Anyway, curl request, you can dump the output to whatever you want, but we can set power on. So currently it's on at the moment, we'll set power 0. So you can just do a curl request to the API, it's just using query string parameters. There's a get request, press enter on that. And of course curl is installed in this machine, isn't that typical? Do I have wget at least? I've got wget, we can wget that. Wget is going to save it though, isn't it? I'll live with that for the minute. Yeah, so they're gone. Maybe not. Ah, set power 1, set power 0. There we go, off. So curl's probably more beneficial, but set power 1 if I press enter. So yeah, I've just got that running in a cron tab script, which is a bit like task scheduler for it's like task scheduler on Windows, but for Linux, cron tab. And then you can do various other commands like set mode. I don't know what I can't remember what the modes are off the top of my head. There you go. Whatever that is. Probably custom color or fade. I can't quite tell yet. So you can do stuff like that. So you can change the mode via the API. Obviously what you want to do is dump this output to dev null, but because it will it's probably saving these as pages with curl at the moment. So yeah, that's just an example of the API. Oh, so I've got it set to some sort of, I think it's on a fade mode, but it's set very slow. I'll just switch back to the web interface. Back on the web interface. We'll adjust the speed, make it faster. You should see a change up here. You should see it changing much faster now. So I've just adjusted the slider on there, and I've hit set, and it's now going much faster. And this is all changeable via the API as well, so thanks to query string parameters and get requests. Yeah. That is the OpenFusion Lighting Controller with the API and a couple of demonstrations. I'm only running on a small section of strip here at the moment. I can run it on a longer strip, but then I have to sort of pan over. But that just shows you that. It's got a couple of test strips. I'm working on potentially porting directly to Raspberry Pi if I can, using the C library, was it WS2812 library, which is a user space package. So it runs in user space and can drive these, but that'll be a task to see whether the Raspberry Pi can support the timings that I require. because it's dependent on the CPU clock speeds. The Arduino is certainly fast enough because it's low level enough, even though it's only 8-bit. But yeah, that's the OFLC. Hopefully I'll get some custom boards at some point as well. Some custom spun PCB boards, so it's more plug and play. Primarily just focusing on the smart LEDs these days at the moment, as they're quite superior. So let's leave it on a Knight Rider. So we're going to switch mode to Knight Rider. Click it with my mouse down here. There we go. And it's remember the last colour we've got it set to, which is some sort of yellow there. And I can probably speed it up if you want to. Wrong direction. I need to go the other way. That's faster. There we go. So thanks for watching. Long enough video. Bit long-winded, but you kind of get the gist of it. Shows you that there's an API, etc. I can do smart lighting like Philips Hue without any proprietary software. It's all running locally. It's all got a web interface. I can control it in curl, have it automatically come on, come off, change mode at different times. If I want, I could run the cron tab on the Raspberry Pi itself, but I call it from another machine, a different machine on the network. It does a curl request to the API. But I thought I had to add some more details on a bit of a status of the OFLC. So thanks for watching, and cheers for now. 2 Echo 0 Papa Golf Sierra clear.